Okay, here is the key to your review. So as you start working through right triangles now, keep in mind that not every right triangle is special. So you have to decide whether or not it is before you start. So in this case here, I do have a right triangle, but I don't know anything about these two angles. I don't know that it's an isosceles triangle, possibly that it could be, but I just don't know any of that. So I can't use the special right triangle stuff since I don't know if it's special or not. But I can use Pythagorean theorem here. So I will do x minus 2 squared. Remember, this has to be in parentheses because there's more than one term. Plus 4 squared equals x squared. Then here, this does not become x squared plus 4. No, no, no. You are squaring a binomial, which means you get a trinomial. It is x minus 2 times x minus 2. So like I said previously, you don't know how I'm about to get what I get, then you need to go spend some time on Khan Academy. It's fine if it takes you some work off on the side or whatever, but you need to be able to do it correctly. So when I square this, what I get is x squared minus 4x plus 4. Plus 4 squared is 16 equals x squared. So it looks like it's a quadratic, but if I subtract x squared from both sides, and I'm going to combine this at the same time, this will give me negative 4x plus 20 equals 0. So I subtracted x squared from both sides, and I combined these two. So now I get 20 equals 4x, and x equals 4. Okay. So then this next one, again, could be a special right triangle. I really have no idea. So this gives me 14 squared plus x squared equals x plus 2 squared. Again, here, I do not get x squared plus 4. You have to square the binomial. So 14 squared is 196 plus x squared equals x squared plus 4x plus 4. So then looks like a quadratic, so I subtract x from both sides to try and set it equal to 0, and I get 196 equals 4x plus 4. So 192 equals 4x, and then x equals 48. Number 13, the aspect ratio of a TV screen is the ratio of the width to the height. Make sure you're paying attention to width to height, so you know which is which in your ratio. Draw my little picture here. So the width to the height is going to be 4x, 3x, and the diagonal is 42 inches. Okay, so I'm going to do Pythagorean theorem. So this is 3x squared plus 4x squared equals 42 squared. So 3x squared, when you square the whole thing there, you actually get 9x squared plus 16x squared equals, and if you square 42, you get 1764. So 9x squared plus 16x squared is 25x squared equals 1764. So x squared equals 1764 divided by 25. Well, I don't care about x squared, I want x. X is the square root of 1764 over 25. That is the same thing as the square root of 1764 over the square root of 25. Okay, so I need to simplify these if I can. Always try and reduce the fraction if you can too. I can't, but so I don't need to go do some crazy tree on 1764 because I know two numbers that multiply to give me 1764. They are 42 because that's how I got it originally. So this becomes 42. Square root of 25 is 5. So x equals 42 over 5. It's not my answer. It's asking me for, it says find the width. All right, so the ratio of the width to the height, this is the part that's the width right here. So I don't have to go back and substitute it into everything. I just have to substitute it in there. So I get 4 times 42 over 5, 4 over 1. So 4 times 42, if I double it, I get 84. Double that again, and I get 168. So this is going to give me that the width equals 168 over 5. Can't reduce that, and that is inches. Leave it like that for now. Okay, now we're going to find the missing side length and decide whether or not it is a Pythagorean triple. Which means I'm doing Pythagorean theorem to begin with. So 24 squared plus 32 squared equals x squared. So you should know your perfect squares to 25, so you should know that 24 squared is 576. Plus 32 squared, you may not know that off the top of your head, and that's okay, but you should be able to figure it out correctly, and that is 1024. That is equal to x squared. So that means then that x squared equals, when you add 576 and 1024, you get 1600. So that's a big number. I need to take the square root of it. It's really not that bad. It's the square root of 1600. So if you think about the tree, two numbers here, I get 16 and 100. Those are both perfect squares. So they both come out, right? 16 comes out as a 4, 100 comes out as a 10. 4 times 10 is 40. So x equals 40. That's part of my answer. So there's my missing side length. All three of these are non-zero whole numbers, so does it form a Pythagorean triple? Your answer is yes, and your work is your answer. Your work is your explanation. Okay, so then, now we are going to tell if the measures can be the side lengths of the triangle. Dang it. And then classify the triangle as acute, obtuse, or right. So, for step 1. Whether or not it can even be a triangle. So I find the smaller two sides, so 9 plus 12, and I want to know how is that related to 16. So this gives me 21, it's greater than 16, so yes, it forms a triangle. If the answer is no, I don't have to do anything else. So now I go on to step 2, and I see what happens in the Pythagorean theorem. So 9 squared plus 12 squared, blank, question mark, 16 squared. 81 plus 144, 256. So then 81 plus 144 is 225. 225 is less than 256. Okay, so since it's less than, it is not a right triangle, but less than means that it is an obtuse triangle. So we move on to the next one. Step 1, does it even make a triangle? So 2 plus 3.7 is blank 4.1. Well, this is 5.7 is greater than 4.1. So the answer is yes, it makes a triangle. So then I put it in Pythagorean theorem. Get 2 squared plus 3.7 squared, blank, question mark, 4.1 squared. So I know that 2 squared is 4. You might need to go off to the side and do a little bit of work. And when you're done, so that you know that whether or not you did your decimals right, you didn't put them in the wrong spot, that's a little less than 4, so you know this has to be less than 16. So you think about that. You get 13.69, like question mark. And then 4.1 squared, that's going to be that has to be a little bit more than 16, so that is 16.81. So when I add these together, I get 17.69 is greater than 16.81. So since it is greater, this is an acute triangle. All right, 6, 8, 10. So 6 plus 8, blank, 10. This is 14, is greater than 10. Well, it is greater than or equal to, but I don't really know the blank. But the answer is yes, it makes a triangle. So then, in the Pythagorean theorem, I get 6 squared plus 8 squared, 10 squared. So 36 plus 64, 100. So 36 plus 64 is 100. There we go. So I get 100 equals 100. Since those two are equal, this is a right triangle. There is part 1. Okay, so I want to find the value of the variables and give my answer in simplest radical form, if there is a radical form, just simplest form. So here I can use the triangle proportionality theorem, right? This is not the mid-segment because this is not the midpoint. However, it does divide the sides proportionally. If I'm looking for the length of CE, I can call that x, and I have fractions to set up. 12 over 8 equals 15 over x. You can simplify this first if you want. 4 goes into 12 3 times, goes into 8 twice. That's equal to 15 over x. So then when I cross multiply, I get 3x equals 30. So x equals 10, and that means that the length of CE equals 10. Same thing here. This is, since these are both right angles, that means that these are corresponding angles and they're congruent. So these are parallel, which means I can use the triangle proportionality theorem. I will call this x. So I get 10 over x equals 9 over 3. So I can reduce this if I want to. Yeah, it just becomes 3, but if I want it to remain in proportion, I've got 10 over x equals 3 over 1. So that gives me 3x equals 10. So x equals 10 thirds, which means the length of ST equals 10 thirds. Okay, parallel, so I can use the triangle proportionality theorem here. Got y minus 2 over y plus 1. That equals 3y minus 10 over 4y minus 11. So can I just cancel these y's out? Heck no, I can't cancel those y's out. So I need to cross multiply. This is going to give me y minus 2 times 4y minus 11 equals 3y minus 10 times y plus 1. Okay, so you have to know how to multiply these correctly, whether you do distribution, whether you do FOIL, whether you do the box method, whatever you do, you just got to be able to do it right. So when I multiply these two together, I'm going to get 4y squared. It's going to give me a negative 8y and a negative 11y, so I'm going to get negative 19y plus 22, and then that equals 3y squared. I'll have negative 10y and a positive 3y, so minus 7y minus 10. Okay, so that sure looks like a quadratic to me. So I'm going to set that equal to 0. I'm going to move it all over here so that the y stays positive. So when I subtract 3y squared from both sides, I just get y squared. I'm going to add the 7y here, so I get minus 12y. And then I'm going to add this, so that it gives me plus 32. That equals 0. So now I have a quadratic. I have two possible answers here, most likely. Sometimes it's a repeat. I'm going to factor this. Okay, so notice how I never lose my equal sign. There's not a GCF I can factor out first. So I know that this is y and this is y. Since this is positive, that means the signs have to be the same. Since this is negative, that means it's both negative. So I need two numbers that are going to multiply to give me 32 and add to give me 12. That would be 4 and 8. So when I solve this then, that means that y equals 4 and y equals 8. Well, maybe they both work, maybe they don't. They're both positive. When I substitute them in, there's really nothing that would happen with any of them that would have caused any of these side links to be negative. So I have two answers here, two different possibilities. All right, so if these triangles are similar, we're going to write angle, angle, side, 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 or side, angle, side. If not possible to conclude that they're similar, write not possible. All right, so on these, you want to make sure that you can state what you know and why. And I did not do a good job of putting a decent example of these on here, but I know that angle S is congruent to angle D. I know that because it's given. I know that angle T is congruent to angle C because that's given. Right? If I had vertical angles, I'd have to talk about vertical angles or something like that. But I have two sets of congruent angles here, which means that the triangles are similar. So triangle RST is similar to triangle BDC by angle-angle similarity. So over here, E and Y, those two angles are congruent. Not because it's given, but angle E is congruent to angle Y because all right angles are congruent. Then I have to set up ratios for the sides. So I can put CE, the length of CE, over the length of WY. That should be equal to the length of ED over the length of YX. So that means it gives me 3 over 1 equals 12 over 4. And this does become 3 over 1, so I'm good. So I've showed that my sides are proportional here. So now I can say triangle CED is similar to triangle WYX by SAS similarity. All right, so here I'm supposed to separate and redraw the statement, a similarity statement comparing the triangles. Dang it. So I would go ahead and label these. I think that helps greatly. I'm going to redraw the original one. Right angle. This is the big one, so this is PRQ. Then I'm going to draw the other two, so here's the medium, and here's the small. Okay, so here's my medium triangle. My medium triangle, the right angle is S. And in my medium triangle, the only angle I have labeled is this one that has to correspond to this one. So this is Q in my medium one, which leaves this to be R. In my tiny one, my right angle is S. The only angle I have labeled is this one, which has to correspond to P, so it has to be over here. This has to be P. So PS, that leaves this to be R. So now I have my triangles turned where everything corresponds. So PQR is similar to triangle RQS. And pay attention to whether or not the triangle symbol's there or not. Some people are leaving that off when it's not there for you. PQR, RQS, PRS. There's page 2. All right, so the next one. Now we're doing geometric mean. So remember, you have a large triangle with an altitude. Yes, there's 3 triangles here, but when you're doing geometric mean, you're only looking at the big one if you're not separating and redrawing them. And you have the legs and the altitude are the only things that get squared. You don't start by just squaring the variables. It doesn't work that way. So this leg, this is a leg of the big triangle, and it's a geometric mean. So the leg squared is equal to the piece that's the hypotenuse that's attached to it times the whole thing, which is x plus 12. Then I can move on to the altitude. The altitude is 6. 6 squared is equal to the 2 pieces multiplied together, so 12 times x. Then this other leg is a geometric mean. Y squared is equal to the piece that's attached to it, which is x, times the whole thing, which is x plus 12. Got all 3 of them written down. I start where I only have one variable, which is here. So 36 is equal to 12x, so x equals 3. There's x. I can plug x into right here. So I'm going to get z squared equals 12 times 3 plus 12. So z squared equals 12 times 15, right? And then 12 times 15 is 180. You could do 12 times 30, which is 360, and then half of that, because 15 is half of 30. But z squared is equal to 180. Okay? So then z is equal to the square root of 180. I can do, I know this is 12 and 15, right? This has to be 3 and 5. this has to be 4 and 3. So 4 is a perfect square. 3 is going to come out as a pair also. So I'm going to get that z is equal to, the 4 comes out as a 2, the 3 comes out as a 3, so that's 6 square root of 5. Now I can take the 3 and substitute it in right here. So y squared equals 3 times 3 plus 12. So y squared equals 3 times 15. Y squared equals 45. So y is the square root of 45. 45 is 9 and 5, which means that y is 3 square root of 5. All right, so on this one, triangle, this is a leg. Start with the leg. Leg squared, square root of 6 squared is equal to the piece of the hypotenuse that's attached to it times the whole thing is 1 plus x. Then the altitude, y squared, is equal to the two pieces multiplied together. This leg, which is z squared, is equal to the piece of the hypotenuse that's attached to it times the whole thing. Two variables, one variable. Let's start here. Square root of 6 squared is 6. That's equal to, well, when I distribute that 1, I just get 1 plus x, so x equals 5. Substitute that in here. So I get y squared equals 5. So y is square root of 5. Substitute 5 in here and here. So z squared is equal to 5 times 1 plus 5. So z squared equals 5 times 6. Z squared equals 30. So z equals the square root of 30. So when I do my tree, I can do 3 and 10 and 2 and 5, and there are no pairs to take out at all, so z is the square root of 30. All right, so we've got right triangles again. This is a special right triangle. If it is a special right triangle, I will not accept it if you do Pythagorean theorem. Okay, and even though I know some of these are easy and some of you are catching on pretty quickly, you still have to show everything or you're not getting the credit. So yes, you absolutely have to label the triangle. L squared root of 2. That's something that I'm looking for. Then you have to set up your little equations. L equals 26 and x equals L squared root of 2. Do not substitute anything until you have solved for what you need. So you find the equation with one variable. Bam, here it is. Solve. Well, this one's solved for me, so I don't really have to do anything else. L is 26, so when I put it in over here, x equals 26 square root of 2. So that one, super simple. But yes, you still have to show me everything else so I know you understand what's going on. So then here, this doesn't have any angle measures, but these are congruent, which means it's an isosceles right triangle, which means it has to be 45, 45, 90. So L square root of 2. Yes, you have to do that. Then you have to set up your little equations. X equals L, and 12 equals L squared root of 2. Do not substitute now. You find the equation with one variable, you solve for that variable, then you start substituting. It's going to make things more complicated later if you start doing that. So here I'm trying to get L by itself, which means I'm going to divide both sides by the square root of 2. So those cancel out. So I'm left with L equals 12 divided by the square root of 2. Can't leave a square in the denominator, so I rationalize. So L is equal to 12 square root of 2 over 2. Then I need to simplify. I cannot cancel those out, but I can simplify this, so this gives me 6 square root of 2. So that's L, and then now that I've found L, I can substitute it in right here, which means that x equals 6 square root of 2. All right, so then here, 45, 45, 90. So I do L square root of 2. Write down my equations. L equals 16 square root of 2. X equals L square root of 2. Two variables, one variable. It's solved. That's fantastic. So now I can substitute. X equals 16 square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is 2. So this is 16 times 2, which means x equals 32. Okay, so now I'm solving proportions. I'm actually going to stop this video here and then I will pick back up.